Assalamu alaikum. Bismillahir Rahmanir Rahim. In the name of Allah, the most beneficent and the most merciful. Guys, today in my lecture, I'm going to explain you about what is the domain of modulus function or absolute function, right? So I'm going to write down here domain of modulus function. Modulus function, right? Or sometimes it is called absolute function. Absolute function. Right? And the representation of absolute function is y is equal to fx, which is equal to mod of x. This means you have to use this two vertical line, and between that you have to write x. So this means absolute function. What does it mean and why we use this one? Remember one thing, the nature, the behavior of such function is it always give you the positive values of it. Remember one thing, whenever you need the positive values of y, you have to write the function in absolute form. Okay, so here as you can see where x belongs to real number, means if you say, right, so remember one thing, whenever you are here, okay, 0 or greater than 0, this side, right, on the right side, so mod of x, this mod of x, if you are going to give any positive values of it, this x greater than 0 means the value has the positive values. Okay, so whenever you give the positive value of x, the nature of this function is this is always equal to x. I am going to mention here, this is very important. Whenever you have mod of x, whenever you will see the mod of x, it has two function. It has, means this one has two function. One is x, this one, and another one is minus x, means the magnitude is the same but opposite in nature. This one is positive and this one is negative, right? So whenever you see mod of x, this is always equal to plus x, or you can say this is what, minus x. So this function has two functions, right? Means mod of x is equal to x or mod of x is equal to minus x. The question is when we will say that this is equal to this one and when this is equal to this one. This is the question. So I will say here, if the value of x is 0 or greater than 0, if this value is 0 or greater than 0, we will say that this is equal to x. Only 0 or greater than 0. So you can see this value is what? 0 or greater than 0. So when mod of x, where x is 0 or greater than 0, we can say this mod of x is equal to x. So the graph is always this one, right? This is what, y is equal to x, or you can say mod of x is equal to x, right? When x is 0 or greater than 0, this is always what? X, means y is equal to x, the linear equation, right? And second, when you are here, this side, means when x is less than 0, means you are this side, right? So mod of x is equal to minus x if x is less than 0. This is second condition. When the x is less than 0, means when x has a negative value, you will say that this is equal to minus x. So here you can see, whenever we have x less than 0, means whenever we have a negative value, because this means a positive values of x, positive values, and this one is what? Negative values of x. negative values. Okay, so whenever x is less than 0, mod of x is equal to minus x. So the graph of minus x is always this one, right? I already told you in my previous lecture. This is y is equal to what? Minus x, where y is equal to what? Mod of x. So we can say the graph, you will see the graph of mod of x is always v shape, right? Okay, I'm going to tell you some important quality of a modulus function. Number one, or you can say nature of modulus function or absolute function. Absolute function. Number one, the graph is V shape. V shape. You will find V shape, okay? I'm not talking about any reflection, I'm just talking about mod of x or any transformation in the right side or left side in horizontal translation of the vertical translation, right? V shape. Second, this one always, this function will give you the positive value of y. Why? Because here, you know, the x is positive, the domain is positive, so this is always positive because the graph is up, right? Here, even you are in the negative side, okay, the domains are negative here, but no problem, the function had this function is symmetrical to the y is equal to x, so you can say this has the positive values of x, right? Meaning in both cases my graph is up, right? So you cannot say that the mod of x have the negative value. For example, if somebody has written this one, mod of x is equal to minus 3, you can say no, impossible. Impossible. Because mod of x will give you always positive value. So you can say the range is always positive value. 0 or the positive values, right? So you can say it always give you the positive value. Mod of x has a positive values of x. In another language you can say the range is always, I will tell you the range in my next lecture. The range is always what? 0 or greater than 0, means all positive, right? And the third one, this is even function. Even function or an odd function I will explain in my next lecture. I want to tell you means even function means if you are going to give the negative value of x, but it will always a positive value of x, then you can say this is even function. So you can say this is also an even function, right? Even function. Okay, and the fourth behavior, the last behavior that we have to discuss today, the domain of the modulus function. Because my next question will be based on modulus function. We will solve a lot of questions based on modulus function. Find the domain, find the range, a lot of complicated function I will give you. But if you don't know the concept of modulus functions, you are not able to solve this one, right? So you must know about the domain and the graph of this function, right? Okay, so as you can see here, if you have 0 for this real line, if you have 0 or greater than 0, or you have less than 0, for each and every value of x, you have fx, means the function is always defined. You cannot say, sir, we have one value of x where the function does not exist. No, impossible. For minus infinity to positive infinity, for each value of x, the function always exists. So the domain of absolute function, is real number. So the domain the domain of absolute function is real number. It's a real number. And that is why when I was explaining you about how to find the domain of a quadratic equation, and the quadratic equation is written in square form, right? So the domain is always a real number. Why? Because that square form is equal to modulus form. I'm going to give you one simple example here so that you can understand. Here, I discussed this one in type E. For example, we have type E, and the question is this one: y is equal to, for example, I have x square plus 8x and plus 16, for example, right? So as you can see, this is a means we have to find the domain, right? The question is domain. Find the domain. See, here the discriminant means b square minus 4ac. Okay, b is 8 whole square minus 4, a is 1, and this is 16. 8 is 64, 16 multiplied by 4, 64, and this is 0, right? So d is equal to 0 means this can be written as, or we can say this quotient can be written as x plus 4 whole square. Okay, means when d is 0, this equation can be written as this one, right? And as I told you about the modulus function, this graph is the same as, you can say, the modulus of what? X plus 4. And when you have x plus 4, the graph of this one and the graph of this one is the same, right? So x plus 4, when you are going to draw the graph, you can see this is plus 4. So remember one thing, come on the left side at minus 4 here. For example, this is minus 4. So draw one line here, one line here. This is what? Modulus function. As I told you, the domain of absolute function or the modulus function, both are the same thing. So here, the domain of this one is a real number. Because I know the domain of modulus function is always a real number. So the domain belongs to from minus infinity to positive infinity, or you can say a real number. Okay, so I hope guys you all understand, and please watch my next video where we are going to give you some questions based on absolute functions. Okay, and we will find out the domain of that. That will be a very important lecture, so please don't miss it, and please have a look on that. Inshallah, meet you in my next lecture. Take care. Bye bye.